Hello and Assalamualaikum. My name is NAUFAL bin LATIFF. My supervisor who is Encik Muhammad Rafi bin Omar. So my project is for the PSM one. My topic is the comprehensive study on selective laser sintering 3D printer, polyamide recycled composition and dimension measurement accuracy effect on automotive application. This is my main contents. Many in the industry now recognize 3D printing as a six manufacturing process with widespread use. This 3D printing uses various materials like plastic and metals to make three-dimensional goods layer by layer based on a digital model, rather than using physical labor and mechanization. There's been an enormous expansion in this field, with dozens of equipment manufacturers and hundreds of thousands of 3D printed items already on the market. What all of the processes and technologies have in common is the manner in which the production is carried out layer by layer in an additive process, which is in contrast to traditional method of production involving subtractive methods or molding, or is it called casting processes. My research of 3D printing to be used is powder bed fusion, which is selective laser sintering, SLS. This method uses either an electron beam or laser to melt or fuse the material powder together. The material used in this process is polyamide 12. Selective laser sintering (SLS) is example of the powder-based 3D printing technologies, and selective laser sintering can used to create metal, plastic, and ceramic objects. My study evolved into three problem statements, which is the first one is SLS polyamide 12 but have a grainy surface. The second one is the necessary dimension may not be obtained because to the shrinkage. And the last one is which polyamide 12 composition percentage is the superior one. My study comprised of three objectives, which is the first one is to optimize the composition of virgin material, unsintering material, and recycled material of polyamide 12, and second is to obtain high precision and accuracy of the produced part. And the third one is to acquire the guideline for a superior composition of polyamide 12. Scopes of study. First is optimization of 3D printed powder material percentage composition using temperature method. Second one is to test the sample of polyamide 12 by using few of testing machines, which are for roughness test, and surface morphology, and dimension accuracy. And the third one is validate the precision of fabricated product by using calibration block and standard vernier caliper. Literature review parts. Okay, the first one is what types of 3D printing technologies using nowadays. So the first one is binder jetting. Binder jetting is a rapid prototyping and 3D printing process in which a liquid binding agent is by selection deposit to mix powder particles. The second one is directed energy deposition. Directed energy deposition is a more intricate printing process commonly used to fix or add additional material to existing component. The third one is material extrusion. Material extrusion-based 3D printing technology can be used to print multicolor and multi-material printing of plastic, living cells, or foods. This process can create totally functional product parts. Fused deposition modeling (FDM) is the first example of a material extrusion system. The fourth one is powder bed fusion. The powder bed fusion process comprises selective laser sintering (SLS). This method uses either laser or an electron beam to fuse or melt the material powder together. The example of the material used in this process are metals, polymers, ceramics, composite, and hybrid. Selective laser sintering (SLS) is the core example of the powder-based 3D printing technology. The powder bed fusion divided into two categories, which is the selective laser melting and the selective laser sintering. The fifth one is the material jetting. So according to standard of ASTM, material jetting is a 3D printing process in which drop by drop of built material are selectively deposited. In material jetting, a printhead dispenses droplets of the photosensitive material that solidifies, building a part layer by layer under UV light. Simultaneously, material jetting builds components which all fully switch surface and high dimension accuracy. FDN have their advantage too and disadvantage. application materials for each 3D printer. So the second one is SLA, and the third one is SLS. So each of the 3D printer of SLS have their own advantage, disadvantage, and application, and their own materials. So mostly for the application of FTM is um, for the basic proof of concept models, and the SLA functional prototyping, pattern molds and toolings, dental application, jewelry prototyping and casting, and model making too. And SLS can be a variety of things, so functional prototyping also, short run, bridge or custom manufacturing. The typical material for these 3D printers for FDM, standard thermoplastics such as ABS, PLA and their various blends. SLA use many types of resin, thermosetting plastics, standard engineering, APS light, PP light, flexible, heat resistant, castable, dental and medical biocompatible. SLS, as we all know, we use the typical one is nylon 12 and nylon 11s and other composites. There is 4 main tests that we run for my specimens. So the main test is first one is a hardness test. So we use the mid-to-tire rod wheel hardness test to determine the hardness of the material by measuring the net increase in the imprint depth as a force is applied. So the values such as R, L, M, E, and K scales are often used to represent the hardness number, so which have no unit. Next test is surface morphology. So we use the SEM, which is the scanning electron microscope. That is a tool for creating image of the otherwise invisible worlds of microscope. Invisible world of a microspace. So SEM have the ability to magnify an object up to 300,000 times. An SEM image typically includes a scale bar. The scale bar is used to calculate the size of the image feature. Next one is the surface roughness test. So we use the material surface SJ 410 surface roughness measuring instrument to measure both skidded and skidless. The SJ 410 surface roughness measuring instrument includes 46 roughness parameters that meet the most recent the typical standards. So for the materials, 3 types of the material that are commonly used. Also the first one is metals. So metal 3D printing technology gains several attention in aerospace, automobile, medical application and producing trade as a result of the benefit of existing by this process. Next material is ceramics. So currently 3D printing technology can manufacture 3D printed objects by exploitation ceramics and concrete without massive pores or any cracks through optimization of the parameters and set up the great mechanical properties. The last one is polymer. So 3D printed technology are widely used for the production of polymer components from prototypes to functional structure with tough geometries. So the 3D printed polymer material in liquid state or with low melting point are widely employed in 3D printing industry thanks to their low cost, low weight and process flexibility. For the polymer mechanical properties, so 3D printed polymer parts has its own different mechanical properties compared with our traditional methods. So the polymer is more to the advantage of flexibility. So it's less stiffness compared to the other manufacturing method. So as you can see here is the table of the mechanical properties of the polymer, which is comprised of crystalline and amorphous. So we use the crystalline one. So this is the polymer applications, the typical one. So polymers for the 3D printing product, the common application that are also being used is at the medical, electronic, aviation, and automotive. So for the melting points of the polymer, so as you can see the pyramid pyramid stage. So the red one is representing the SLS types of material. So for the designing, for the engineering designs, from drawings, CAD and CAD, transfer into the driven data. So this is the typical of the designing software for the the main one. So we can use the Autodesk generative design. So the second one is have parameters. It use the reverse engineering tool. Okay, the next designing technology, which is what I will be used for my research. So that is the function technology software solution. So for this function technology, we use two types of software for the designing. So the first one is the BuildStar, and the second one is the MaxStar. So effects of the different change of parameter play a good deal of influence on the mechanical properties of the 3D printed object. So to obtain the desired mechanical properties, the parameter need to be put into consideration. So the first one is we have to consider is laser power. So the laser intensity influence 2 photon absorption and the polymerization process by a factor of 2. And as a result, the laser power influence the pace of initiation reaction in the current model, and the active center formation rate varies greatly for the different laser power. The second one is we have to consider the layer thickness. Based on this study from Shubham to 2016, tensile strength is lower by 46%. Impact strength is reduced to 54%, and the hardness is reduced to 40% as the layer thickness increase, and the exception is the layer thickness 0.5 mm. So this is as a result, as the layer thickness increase, the mechanical characteristic of the material also diminish. This is my research gap that I have collect around my period for this PSM1. So there is four uh, four of the study that I have read. So the first one is from Encik Rafi himself. So his study is around the laser power chamber, temperature, laser speed, layer thickness. This is the parameter variable that he tried to put into the scope, and the material is polyamide 12, which is the same as that I will be using. The study including the virgin material, recycled material, physical properties, roughness, surface morphology. So this is the test that have been run in the project, in the research. So for the next one is Young 2020. It's around the parameter around tensile strength, elongation, onset temperature, scanning spacing, layer thickness, laser power, and laser speed. And it's also used the polyamide 12 material. So it runs several tests, which is surface morphology and hardness. So there is two only. Also have physical properties, recycled material, and virgin material. And the next one is LMIS 2018. So the scopes is around layer thickness, different layers, wettability, printing temperature. So the material used is polylactic acid. So he used the virgin material too, and some of test is roughness and surface morphology. And the last one is Chat 2019. So the variable parameters which he put into consideration is laser power, scan speed, microstructure, density, layer thickness. So the material is he's using the alloy one. So use virgin material, and for the testing he use only the surface morphology. So he also study about the physical properties too. This is methodology for the chapter 3. So as you can see, this is my flowchart. So my research methodology, the first one is of course a literature review. So for this literature review, before I run my experiment, I have to read several of the previous researchers within the 5 years gaps. 5 years gaps. So from this research studies, I can learn many things that I have never learned before. That's around for my scope, which is 3D printing SLS using the material of PA12. So from here um, I can see what their research is about, what their study scope. It is the same with the last one that I explained, which is the research gap. So I can see what testing method they use, what materials they use for their studies, and from there I can get many sources that I can that will be useful for my study in this phase one. The next step is sample preparation. So for my sample preparation, uh, I will cut the specimen of PA12 with dimension of 10 mm plus 10 mm the area, and with the different composition for each specimen. So after that, I will run several tests, which is the first one is hardness test. So for the hardness test, we use the Rockwell R hardness with the parameter of PA12 or specifically. So this is according to STM standard. So the total force, as you can see here, is the total force value is 107 Newton, and then we place the specimen on the surface testing machine and set the gauge to 0. And after 15 seconds, I will remove the major load, so let the specimen recover for the 15 seconds and read the dial. This is the specimen for the hardness test dimension according to the ASTM standard. This is the dimension from the drawing I do. So the thickness is around 6 mm, and the line is 20 mm, and the width is 20 mm too. The next test will be roughness test. So after run this experiment, I will obtain the values of RA, RQ, and RZ. So it will display on the LCD screen of this machine. So the parameters that I will set is travelling length, which is 5 mm, stylus tip radius 2 mm, detecting force 4 micronewton, this specimen size. This is for the according to the standard to run the roughness test. The next test will be surface morphology. So before I run this test, I have to coat the specimen first and set the range between 0 to 90 degrees and set the magnification for 50 micro and 200 micro, and for the EHD value is 15. So this is the testing machine that will be used, SEM ZES Evo at electron microscope, and the pictures below is describing of the example of SEM image that I will get. But this one is for the polyamide, for the unsintered one. So it's before the heating process. For the material composition, so this is my composition for the PA12. I have two specimens that I have their own different composition. For the first one is comprised of 100% of virgin material, and for the reheat recycle is 0. We put to 0, and then next composition is 50-50 for the recycle and the virgin, and the third one is 100% of the recycled composition. The next step is 3D print. So 3D print commonly have 4 4 processes, which is pre-process, and the second one is 3D printing process, and the third one, I'm sorry, I have typo here. So the third one is for the post-process, and the last one is final product. So you can see here the pre-process. First use the CAD. So this is how we determine our design early stage, and the 3D process from the process inside the chamber itself, and the pre-process is I'm sorry for the post-process is for the get our product outside of the chamber, and we do some tests for the specimen, and the final product is the typical of the coloring, coating. That's it. So the picture here shows the SLS 3D printer types that I will be using, which is Falsun 4092P. So the last testing, which is my main objective. My main objective of this study is for the accuracy itself. So after the run the several of the tests, so I will be printing by prototyping the specimens, and then after I receive the products, then the products is standard blocks dimension. So I'll be using these tools, which is standard vernier calipers and the calibration block, to measure the accuracy of the 3D printing scanner. This is the product design. So this is as you can see, this is the typical blocks. So from here I can use the tools that I've mentioned before, which is vernier caliper and the calibration block. So this is the accurate dimension. So even the tiny bit of the millimeter, I will put into the consideration of the accuracy itself. So I will compare from this dimension from the previous specimen and to the produced part of the products 3D printing polyamide 12. So this is my expected result. So the things that I have to that I will be putting into consideration is the factorial input parameter and the expected testing result. So for this one expected result, so this is for my the byproduct of my several of my testing that I have mentioned. So which is hardness test, roughness test, surface morphology, and the last one is dimension accuracy, which is my main objective of this study. And then the testing will be conducted based on my material percentage, which is the composition. So which is as you can see 100V, which means it's my 100% virgin, and 40, which is half of the virgin material and recycled material, and the last one is 100% recycled composition. So the laser power and lightness is fixed, which is stand for 100 for laser power, and thickness is only 0.3. I think that's all from me. So I'm sorry if there is any lags come from me, and I'm sorry also for my if there is any bad delivering method to convey what I'm trying to deliver to you. And then if you have any question, you can ask me for the Q&A session. for the next one coming later. Thank you, and go easy on me.